Hey guys, if you are watching this video, I'm sure you have a basic understanding of Kubernetes. If not, I recommend learning the basics of Kubernetes. I have created a detailed playlist on Kubernetes with a complete hands-on approach. If you learn Kubernetes before continuing with this video, you'll find it much easier to grasp Helm concepts. Well, let's take a closer look at the official definition of Helm. Helm helps you manage Kubernetes applications. Helm charts help you define, install, and upgrade even the most complex Kubernetes applications. Don't worry if it seems a bit overwhelming. In this video, we will closely examine each word of this definition and understand what Helm is in simple terms with a complete hands-on demonstration. So without any further delay, let's get started. As always, before diving into any new technology, let us first understand the problems we currently face with existing approaches and how this new technology solves these problems. With that said, let's begin with problem statement 1. Kubernetes is one of the rapidly growing technologies, and nowadays most of the companies are adopting it. Let's say we want to deploy a simple Spring Boot application to our Kubernetes cluster. For that, we need to create a deployment, service, ingress, and secret manifest. If it's a complex application, we may require many other manifests as well, such as persistent volumes, etc. After creating these manifest files, we apply each manifest with kubectl apply-f command, which can be a tedious process. So, as the number of Kubernetes resources increases, the complexity of storing and applying them also increases. What if there is a way to package all these manifest files into a single bundle and apply as a package with just a single command? That's where Helm comes into the picture. Just like we install something using a single command with apt for Ubuntu, brew for Mac, we can deploy any complex application with Helm in Kubernetes using a single command. And it just works like a charm. In Helm terminology, we call this bundle as chart. And this chart can be installed easily with just a single command. So in short, a Helm chart is nothing but a packaged version of our application manifest files. You might be wondering, what's the big deal here? I can do the same by placing all manifest files into a directory and run kubectl apply-f, giving the path to the directory where we have manifest files. But with Helm, we get many other benefits which we will see in the next problem statements. Let's say our Spring Boot application depends on MongoDB. Deploying this Spring Boot application on a fresh cluster would require deploying the MongoDB first and then the Spring Boot application. But with Helm, you can just relax. Application dependencies can be easily handled in Helm. In this case, all we need to instruct Helm that our Spring Boot application is dependent on MongoDB. Then Helm deploys this MongoDB dependency before deploying our actual Spring Boot application. Don't worry, we will see this in action in a moment. To convince ourselves better on why we need Helm, let's look at the another problem statement. With plain Kubernetes manifest, can we deploy the same manifest as it is in all environments? No, because this MongoDB URI is hard-coded. This MongoDB URI changes from environment to environment. Because this configuration is hard-coded, to deploy it in different environments like dev and QA, we need to copy the manifest with different URIs and apply them separately in all environments, which can be very tedious. Helm templates fix this problem. With Helm templates, we can replace the hard-coded values with placeholders, and we can pass the values for these placeholders from external configuration files using values.yaml. Let's say this is for dev environment. If we give these two files to Helm, it will substitute the value for Mongo URI placeholder. For QA, we can pass the different values.yaml while still maintaining the same template. With this approach, we can deploy the same chart with a different set of configurations in different environments. So Helm allows for better configurability and flexibility when deploying Kubernetes applications in various environments, making the dependency process more efficient and manageable. Let us see one more problem statement. Let's say we deployed an application with plain Kubernetes resources, and let's call it as version 1. Next, we verified the application and everything is working great. Then we made some updates and re-applied the resources. And let's call it as version 2. But this time, when we verify the application, there is some error. And to make it work, we need to roll back to the previous version. While you can roll back deployments and stateful sets with kubectl, some resources such as secrets do not support the direct rollbacks with kubectl. But when we install the same application with Helm, Helm creates a release and stores in the form of a Kubernetes secret. And when we update, it creates a revision for that release. With this, we can easily roll back to a previous version with a single command. How nice and convenient is that with Helm? Not only this, with Helm we can easily package our manifest and share it with our teams and to the world. All they need to do is just run a simple Helm install command. Overall, Helm streamlines the deployment and management of Kubernetes applications, reducing the complexity and enhancing the efficiency of managing Kubernetes resources across various environments. With its wealth of features and seamless rollbacks, Helm proves to be a valuable and convenient tool for the Kubernetes ecosystem. Now that we have a good understanding of what problems Helm solves, let's explore the architecture of Helm. Helm is a command line tool. When we perform any operation with the Helm CLI, behind the scenes it uses its library to prepare the manifest file and to interact with the Kubernetes and handle application deployment smoothly. As needed, it downloads the charts from Artifact Hub, which is a chart repository. As Helm needs to interact with Kubernetes API server to deploy objects, it requires a connection to the Kubernetes cluster. If we already have kubectl installed on our machine, Helm automatically uses the same configuration used by kubectl unless we explicitly specify. Enough of theory. Our channel never teaches something without hands-on. So let's get our hands dirty. Let us start by installing Helm. I'm on macOS, so I'm installing Helm with Brew. If you're on a different operating system, please refer to the official documentation for installation instructions. It's a pretty straightforward process. If you encounter any issues while installing Helm, please let me know in the comment section below and I'll be happy to assist you. So let me install with Brew. Brew install Helm. Please note that Helm is installed outside the Kubernetes cluster, not inside the cluster. As you can see, Helm is installed. We can verify that with Helm version. As you can see, we are using 3.12.2 version. As Helm is installed, we are good to experiment Helm commands now. For the hands-on on Helm, I am using this to-do API service, which is a simple Spring Boot application that uses MongoDB for basic thread operations on a MongoDB collection. To deploy this application onto the Kubernetes, we need a simple deployment and service manifest files. If you remember, these are the manifest files which we used to deploy the same application in the Kubernetes series. Now let us see how we can convert these plain manifest files into a Helm chart. To start with, let's create a simple Helm chart with Helm create command. To this command, we need to give the chart name. Let's call it as todo-API. Enter. As you can see, the chart is created. Now let's get into that folder. Let's open this in the VS Code. As you can see, Helm create command generated a basic directory structure and some template files for our new Helm chart. As we discussed, Helm chart is nothing but a bundle of Kubernetes manifest files. Let us see what each directory and file is in this chart. Chart.yaml file contains the metadata of the chart such as the chart name, version and application version. And templates is the directory which contains the Kubernetes manifest files that are being deployed with the chart. For deploying our simple Spring Boot application, we need a deployment and service. If we need any other Kubernetes objects such as persistent volumes, etc., we just need to add that YAML file simply to this directory. If we don't want any manifest, we can simply delete it from this directory. Next comes the values.yaml. If you see the YAML files under templates directory, there are some placeholders. This is what we were talking about in problem statement 3. With these placeholders, we can parameterize our resources. Values for these parameters can be defined in this values.yaml. This is the file in which all the values that are to be injected into the templates are defined. For example, this image. In our case, this is Pavan Iltepu slash todo API and the tag is 1.0.2. Basically, this is the Docker image of the Spring Boot applications we were talking about. Like this, whatever we want, we can update here or create new values. Example, to our deployment, we need to give the MongoDB URI as an environment variable. For that, let's edit this deployment.yaml. In the interest of time, I'm just copy pasting. As you can see, this is the environment variable and the data is coming from the secret. And the secret name, I'm getting it from the values.yaml. So whenever you see this dot values in this double curly braces, it is coming from the values.yaml. And also if you can see, I have another environment variable which is spring.data.mongodb.uri. Here also I am getting username host from the values.yaml. So as we added these placeholders here, let's go back to the values.yaml and add the values. So these are the values. If you see the nested way that we gave, spring.data.mongodb.username. That's what we gave here. Values.spring.data.mongodb.username. So this way we can pass any value using values.yaml file to any template file in the templates directory. And this syntax is Go template engine syntax. Helm uses Go template engine syntax for templating. I will cover the most important syntax here to get you started on Helm, but you can go through the documentation for more references. This templating syntax allows us to dynamically generate Kubernetes resources based on the values we provide using the values.yaml. Let's say we want to give a default value for the replica count when it is not passed using values.yaml. For that, all we need to do is pipe default 1. So whenever the replica count is not passed using values.yaml, the default value is 1. And sometimes we want to enclose a string in the double quotes. And for that, all we need to do is pipe symbol and quote. So this syntax is used to enclose a value in the double quotes. By using this quote function, Helm ensures that the value is properly formatted as a string, avoiding any YAML parsing issues that might occur if the value contains some special characters. And if you see this range function, this is like a for loop. This is used for iteration over a list defined in the values.yaml file. Example, here we are iterating over .values.ingress.host. If you go to values.yaml, this is where .ingress.host. As you can see, this is an array. So here we can give any number of hosts. Please refer to my Ingress video of Kubernetes series for detailed explanation on what this host is in Ingress. And this if is used to validate a condition. With this, we are giving the flexibility to user to include the ingress or not. So if you see this ingress.enabled in the values.yaml, if it is false, the ingress is not created, but when it is true, the ingress gets created. So for simplicity, let's not create the ingress by making it as false. And this n-indent is a built-in template function that is used to indent a block of text or YAML content by a specified number of spaces. It is particularly useful when we want to format and align the content in our Helm templates. If we don't give this function, by default, all the data that is defined in this double curly braces starts from the starting, which might give the parsing errors. So we should be very careful with the indentation in the YAML file. And this curly braces hyphen at the beginning of a template line removes any leading white spaces or new lines from the generated output. The same applies at the end of the template line that removes the trailing white space. This is useful for maintaining clean formatting in our Kubernetes manifest file. These are just some of the basic examples of the Helm templating syntax. Go templates offer a wide range of features including functions, control structures, and arithmetic operations, etc. Please go through the chart template guide for more information on how to use Go template syntax in our Helm charts. Next comes the underscore helpers.tpl. This file allows us to define reusable template helper functions that can be used across multiple template files in the same Helm chart. This is similar to with defining a method in Java and reuse in multiple places. This is the template block definition. It defines a template named todo-api.fullname. Let us see what we are doing here. This is how we add a comment in the Go templating engine syntax. And this is the body of this template block. Here we are checking if we defined full name override. If it is there, then we are truncating that to 63 characters, and here we are removing any trailing hyphens. This is done to ensure that the name doesn't end with any hyphens. And here we are defining a variable, and this expression means if the name override is not defined, take the chart name as the default value. And finally, we are checking if the name contains the release name. We are truncating the release name to 63 characters and removing any trailing hyphens. Else, we are just concatenating the release name and the name that we defined above with an hyphen and truncating the output to 63 characters and removing any trailing hyphens. So overall, this function creates a default fully qualified app name. The reason why we are truncating to 63 characters is some Kubernetes name fields are limited to only 63 characters. And if the release name contains the chart name, it will be used as the full name. Like this, you can define any complex logics in these template blocks. And this template block can be called from any other template file just by using the include keyword. And next comes the notes.txt. This is the plain text file that gets printed when the chart is successfully deployed. Usually, this contains the steps to follow after the installation of the chart is successful. And we'll discuss about the other files as we move with the hands-on. So now our Helm chart is ready. Let us verify if the values are correct. So this is our image name and this is a tag, and these are the Spring Boot connection details. But where is this MongoDB? As we discussed in the problem statement 2, either we have to install MongoDB separately using Helm install command, or we can just give the MongoDB dependency to this chart and automatically this chart will install the MongoDB. Let us follow this second approach, that is giving the dependency to this chart. To give a dependency to this chart, all we need to do is just go to chart.yaml and add the dependency. So this is the dependency MongoDB. You might be wondering, where did we get this information from? Just like Docker images are stored in Docker registry like Docker Hub, a Helm chart can be stored on the Helm registry like Artifact Hub, which can be accessed at artifacthub.io. So we are on Artifact Hub. Let's search for Mongo, and this is the Bitnami MongoDB chart. When we click on this install button, we get the address of the chart and the version. So let's use 13.16.3. Let's go back. Let's 13.16.3, and this is the address of the Helm chart. And this is the name of the Helm chart. That's what we gave it here. So save it and let's verify other values also. So this is the service. Let's give it as 8082, and ingress for simplicity I'm just disabling it, and also let's disable the auto scaling, and that's it. You can feel free to change any template logics here. Like if you want to remove the probes, all we need to do is just remove the probes here. That's it. So let's delete this service account name also because we deleted the service account file. And if you want to add any if conditions for loops, it's your wish. It's completely dynamic. So as our chart is ready, it's time to install this. It's always a good idea to run a linter before installing our chart to make sure there are no syntax error or we are following the all best practices. To lint, all we need to run a single command, which is lint dot. As you can see, there is one warning which is saying that icon is recommended. For a chart, you can give the icon, just like you can see an icon for this MongoDB Helm chart. The icon can be given in the chart.yaml. So I am giving the icon as my image. And next there is one error. it is saying that chart directory is missing these dependencies. So this error means in chart.yaml we gave this as dependency, but this Helm chart is in the artifact hub. So before installing this chart, we need to download that chart and put it in this chart. For that, all we need to do is Helm dependency build. As you can see, this repo is not there. So before doing the dependency build, we should add the repository to our local. So for that, we should use this Helm repo add. So let's do Helm dependency build now. As you can see, the MongoDB Helm chart is downloaded. After downloading, the chart gets stored in this charts directory. So this is the Helm chart of MongoDB 13.16.3 version. So now we can install the Helm chart. For that, Helm install, and for this installation we should give the release name. So I'm giving the release name as todo-api. And where is our Helm chart? That is in the current directory, so dot enter. As you can see, the chart is deployed, and this is the content that is there in the notes.txt, which gets printed after installing our chart. Now let's try to get the pods. kubectl get pods. As you can see, the MongoDB pod and actual Spring Boot application pods are getting created. So let us give some time for them to come up. Let's try to list again. As you can see, the both pods are running. Please note that by default, when we run this command, Helm takes the values.yaml file from the root directory, but we can give any other file with the -f. So when we run this command, Helm reads the manifest from the templates directory and the configuration from the values.yaml and generates the manifest files with these values. Then Helm sends this generated manifest to the Kubernetes API server. Then Kubernetes takes these manifest files and creates the desired resources in the Kubernetes cluster. If you want to see what manifest it gets generated, all we need to do is Helm template dot. These are the manifest files that Helm generates. And whenever we install a chart, Helm creates a release. A release is a specific instance of a chart that has been deployed to the Kubernetes cluster using Helm. One chart can often be installed many times into the same cluster, and each time it is installed, a new release is created. Let us consider a Mongo chart. If you want two databases running in the same cluster, we can install the chart twice. Each one will have its own release. The release name should be unique in the Kubernetes namespace. We can check the list of releases with Helm list. As you can see, this is our release and this is the first revision. Now let us try to update the Helm chart. For that, let's go to Helm chart and update the replica count as 2. Save it, and to update a release, instead of using install command, we should use Helm upgrade command. Helm upgrade and release name, and this is the directory where the Helm chart is there, and by default it will take the values file. If you want to give any custom path, we can give it with the -f. Enter. As you can see, the chart is deployed and this is the revision number 2. Now if we list down the releases, this is the release and the current revision is 2. If we want to list down all the revisions, all we need to do is Helm history release name, enter. As you can see, there are 2 revisions and the first version is superseded and the second version is deployed. Now if we list down the pods, we should see 2 pods. As you can see, we have 2 Spring Boot pods. Now let us try to change the chart again. For that, Helm upgrade to do -api dot, and now instead of changing the values in the values.yaml, we can directly pass the values with the -set flag image dot tag to 1.0.9, which doesn't exist basically. Sorry, it should be equal. Enter. As you can see, the chart is deployed and the revision number is 3. Now let's try to list down the pods. As you can see, the error image pull because 1.0.9 tag doesn't exist. So now as there is an error, there are 2 ways to fix this error. Either we have to correct the version with the same Helm command, or we can simply roll back it with the Helm rollback command. So Helm rollback, release name, and to which revision number we want to roll back. So let's roll back to the second revision. As you can see, the rollback is successful, and now if we list down the pods, the 2 pods are running because in the second revision we gave the replica count as 2. So now let's see if our to do API application is working fine or not. For that, let's list down the services. Kubectl will get services, and this is the service name.
kubectl dot forward service slash service name, and which is running on the 8082.
So let's go to Postman and hit this API. As you can see, the to do is created. So now let's get this item if it is created or not. As you can see, this data we are getting from the MongoDB. So we verified the data is getting stored in the MongoDB. So let's stop the code forwarding. We can also test our deployment with Helm tests to make sure everything is working fine. We define all these tests in this test directory. So this is the simple test to see if our application is running or not. Let's do some modifications to test our Spring Boot application. So I'm copy pasting in the interest of time. All I changed is I'm using the curl image, and here I appended the /API /todos because that is our valid endpoint of our Spring Boot application. Let's save it. Because we changed the chat, we should upgrade it. Helm upgrade, release name is todo-api dot. Now the chart is upgraded to revision number 5. Now to test this Helm chart, all we need to do is Helm test and release name. As you can see, our test is succeeded. So this is how you can test a Helm chart to make sure your Helm chart is working fine. Now, how do I share this chart with you? Just like Bitnami shared MongoDB chart with me. For that, I need to package my chart and push it to the artifact hub. To package a chart, all we need to do is helm package dot. When we do this Helm package, this dot helm ignore plays an important role. Whatever the files or directories we list here, those are not packaged in this bundle. It is similar to the git ignore or docker ignore. So now let's package this. As you can see, successfully packaged the chart and saved it as todo-api.0.1.0. So basically this todo-api is the chart name that we defined in the chart.yaml, and this 0.1.0 is the chart version that we gave in the same chart.yaml. So now let's create a new directory for pushing this, saying artifact hub, and move this bundle to the new folder. And next we should generate a metadata file containing the available chart. For that, all we need to do is helm repo index, and in which directory we want to generate it, artifact hub, enter. As you can see, this generated the metadata file containing the what is chart name, what is the icon, and what are its dependencies. Now let's push this to GitHub. Added package, commit, and push. Now let's go back to the GitHub and go to the settings and go to the pages and select the branch and select docs and save it. Now copy this URL and go back to artifacthub.io and sign in with any of these options. Now click on this user icon and go to control panel and add a repository here. Please note that not only Helm charts, these all can be pushed to the artifact hub. So let's select as Helm chart and name as Pavanlitapu, and URL is the one that we copied earlier, slash and todo-api is our folder name, and inside that artifact hub is the folder name. So let's paste this and add. Please note that it will take at least 20 to 30 minutes to process this. As you can see, our chart is processed and uploaded to the artifact hub. We can verify that with by searching here todo-api, enter. This is our chart in the Pavan Iltepu repo, and this is the icon that we added in the chart.yaml. So let's open this chart, and here you can add the readme file in your folder, and that appears here. And to install this in our cluster, let's click on this install. And as an initial step, we should add the repository to our local. Let's copy this command and paste it here. The repository is added. We can verify that with helm repo ls. So this is the Bitnami repo that we added earlier for the MongoDB, and this is the Pavan Iltepu repo that we added just now. And to install the Helm chart, all we need to do is helm install, and this is the release name, and this is the repository name, and this is the chart name, and this is the version. So let's copy this command, paste it here, and let's change the release name to remote-todo-api. enter. As you can see, this is the content of notes.txt and this is the revision number 1 and the status is deployed. Now let's try to list down the releases. Helm list. So this is the one we installed earlier and this is the one we installed just now. And let's list down the pods kubectl. As you can see, these two pods are running for this chart as well. So let's port forward this service kubectl get service. So this is the remote to do API. Also we have the remote to do Mongo also. kubectl port forward service slash service name. Let's run it on 8083 and the service port is 8082. Now let's go to Postman and try to create an item 8083. As you can see, the task is created. Now let's try to get the items. As you can see, we are able to get the items also. But there's one tricky thing here. But for this release, remote-to-do-API, we created only one to-do item. But when we are getting the list of items, we got two. Why is that so? Please let me know in the comment section below. I want to hear from you. I will add the answer after 1 week in the description of this video. Now, how do I uninstall this chat? Simple. Everything is a single command in Helm. All we need to do is Helm uninstall and release name remote-to-do-API. As you can see, the chat is uninstalled. Now let's list down the pods. kubectl get pods. As you can see, the remote-to-do-API pods are deleted. So this way we can install multiple Helm charts in our cluster. Let us end this video with some facts about Helm. To address the complexity of managing multiple manifest files in Kubernetes, Helm was introduced at the very first KubeCon conference in 2015. Helm is a graduated project in the CNCF and is maintained by the Helm community. If you don't know what CNCF is, I made a detailed video on it. Please check it out. If you are curious to know why Helm name is given to this, Helm is a device that is used to steer or navigate a ship or boat. In the context of Kubernetes, Helm acts as a steering mechanism that helps you navigate and manage your applications on the Kubernetes cluster. The Helm client and library is written in the Go programming language. Helm stores release information in the form of secrets located inside the Kubernetes. It does not need its own database. When we install a chart, Helm installs the resources in this order, like first namespace, next network policy, like that, and finally ingress and API service. Because if the namespace is not created, where all these resources gets created in. That's why Helm smartly installs all these resources in a specific order. That's it for this video. I'm sure you found it very helpful. My name is Pavanil Tepu and thank you very much for watching this video. If you liked it, please share it with your friends and do not forget to subscribe to my channel to not miss any updates.